First, I want to give a shout out to the organizers, Luke, Kate, Rachel's been doing a ton of work behind the scenes. So thank you for putting together such an incredible panel. We've got some of the industry leaders from across the defense and technology landscape that are harnessing the power of autonomous systems in unique ways and for very different use cases. So it's a real pleasure to be up here with these gentlemen. So before we dive in, let's go down the line, and please, we'll try and keep it to 60 seconds because we've got only 30 minutes up here, but just do a brief introduction of who you are, what your company is, and what you do. So we'll start with Ian down there and work our way this way.
My name is Ian Villa, COO and co-founder of Whisper Aero. We're a next generation propulsion company delivering cleaner, quieter, more efficient thrust. We put our tech into drones in form factors as small as this and much larger. And we also put our tech into the quietest leaf blowers on Earth.
So my name's Chad McCoy. I'm one of the 3 co-founders of Firestorm Labs. We 3D print drones, big ones, small ones, but we're less of a company and more of a con-op, how we view industry and the drone space. Lots of lessons learned from the last speaker and also emerging theaters, but grateful to be here.
Rob Lehman, one of the co-founders at Saronic Technologies. We're a maritime autonomy company focused on delivering the next generation of autonomous capabilities at scale in a timeline that matters. So happy to be here. Thanks again to the hosts.
Thanks, everybody. Joe Woelfel. I run a company called Terradepth. So we're focused on helping people make better, faster decisions with what you do and don't do in the subsea environment, because humanity knows basically nothing about the seafloor. So we build self-recharging drones to stay out for a long time without people having to interact with them, which is a massive limiting factor. We do ocean-going operations, mapping, delivering effects, and we created a data architecture that makes it really easy for non-subject matter experts and like former SEALs like me, so it's got to be really easy to interact with ocean data, whether we collected it or not.
Awesome. Thank you, gentlemen. So on the heels of just hearing from Vlad about the drone warfare and the pivotal shift from the Ukraine war, I think we have to start there. So Chad, I'll direct the first question your way. Hearing the specific issues that they're encountering and the counter UAS and all that, how critical is that feedback from the operators on the ground to validating or even changing your product design?
I think it's important, but I don't think it's the end of the line. I think when we talk about asymmetric warfare, we're talking about guerrilla warfare, right? We're talking about non-traditional kind of solutions to hard problems, and Ukraine is an obvious example of that, kind of disparity. We've learned a ton, but not all of those lessons learned apply to great power competition. Certainly in great power competition, we're talking about mass, we're talking about affordability, we're talking about the communications relays that allow those systems to be effective, and so it's not apples to apples in my view. I think the differentiator, the one takeaway is the insatiable appetite for systems, right? You just need more, and it's thousands a day. Right now, the problem that we're trying to solve is that edge manufacturing when supply chains are cut off. And so I think that's the lessons learned, but we're looking at doing it in massive scale and building systems that they're not exquisite, but they're certainly not $400. We're trying to find that sweet spot where we can proliferate those out to the warfighter in mass in thousands.
Yeah, absolutely. I feel like we've seen that disaggregated organizational structure really come into play in that war. So it's been just over 3 years since Russia invaded Ukraine, and this war has given us a unique window, kind of as you're talking to, about warfare with a technologically advanced near-peer competitor. As we look to strengthen our own defense industrial base, what lessons can we take from this conflict? And I'll frame it this way. What are some things you think that we've learned that we need to absolutely bring on to our own defense system? And what are some things that you've seen that make us say, hey, we have to make sure that we move away from that, whether it's from the GWAT days or whether it's from past battles? So I'll open it to anybody.
I'll take it. So there's a couple lessons learned from Ukraine, and we can get to where those apply to a great power competition as was mentioned, really it is asymmetry. How do you generate effects that are outsized based on the cost and the timeline to get that capability fielded? There is speed, which is critically important because no matter how many drones you build, if they're not delivered in a timely fashion, it really doesn't matter. We say that at Saronic every day. Nothing we do matters if we can't deliver these things in hundreds and thousands on the timelines that our customers demand. And then I think the third and probably the most important, and it's really evident from Ukraine, is reliability and resilience in a contested environment. Within the DoD ecosystem, there is a lot of innovation theater, and if they're not nodding their heads knowingly on the panel, they're withholding their opinions. It's really important that as we go through the S&T development process, that we're really, stress testing these systems with no GPS, with no comms relays whatsoever, so that we're focused on delivering the next generation of autonomous capabilities that are applicable in the fights that we're trying to deter and, heaven forbid, come our way. We have to be able to enable drones that are able to contextualize decision-making at the edge without connectivity. And that's really what we're focused on as a vertically integrated company. We have the luxury of owning the software, the autonomy, and the hardware and manufacturing. And that really allows us to open up the system and facilitate integration so that as the platforms remain relevant over their life cycle, the iteration on payloads and effectors, that timeline is hours, days, and weeks, not POM cycles and fit-up cycles. So our goal is maintain relevant platforms that are able to accommodate a variety of payloads. And on the flip side of that, when these platforms become obsolete or effects have from the enemy render them kind of not the right solution, you have to be able to iterate quickly. And that's faster than what the infrastructure that we have within the DoD environment supports right now. So we're focused on how do we find that sweet spot and help the transition to delivering things quickly at scale that generate asymmetric effects to the enemy.
To stick with the maritime theme here for a second, and this is a bit dislocated from terra firma Ukraine, but I think one thing that this conflict has really shown people is just the susceptibility of critical subsea infrastructure showcased by the Nord Stream sabotage, right? So previously folks thought that, hey, if it's underwater, it's this dark, scary, opaque environment, we must be good. Not the case. And for those of you who don't know, and I think most people do now, 98% of international communication runs through a subsea fiber optic cable. Oil, gas, electricity. I mean, we don't even know how many miles of oil and gas pipeline we've got right now in the Gulf because the subsea environment's super opaque. To Rob's point, it's extremely bandwidth constrained, but it's not invulnerable anymore. And so, as we transition into this potential peer-to-peer conflict, seabed warfare is a term that keeps coming up now that never did previously. And so, one of the first things that's going to happen is critical infrastructure, comms, energy, electricity, it's going to go out, right? So we need to have an understanding from an intel preparation of the operating environment perspective on what this all looks like. So we've all got a map before things kick off. And this is where we get to scale deployment, in my case, in your case, of maritime drones, such that we've got situational awareness, we've got observations, we can orient ourselves, we can make good decisions, and we can act at the speed of tactical relevance. And right now we cannot because we haven't scaled into the operating environments that are relevant with maritime autonomous systems.
I think one of the things I'd add though is that a lot of the problems you're describing used to be soft-only problems or soft unique problems. And what I'm seeing now that's encouraging to me is that the services are adopting this almost a soft mindset to what that technology should provide and some of the mission spaces that they traditionally haven't done because of one, opportunity, also authorities. But so when we talk about mass, that's not a soft thing, obviously, that's scale, but then the actual TTPs and the concepts you're describing fit really nicely in both the large services and the soft community, which is something that I haven't seen. It certainly wasn't the case during the GWAT years, but I think that's an encouraging kind of development. It's easy to be cynical right now of where we're at, but I've seen that across all the services. They're adopting that in a good way.
And on the air side, it's not just what's forward deployed, but we're starting to take these concepts and recontextualize them into other missions. So for example, what we just saw with these drones in Ukraine, obviously the federation of low-cost drone assets changes the way that you conduct war. And when it comes to our bases, right, like the defense of these low altitude defense, air defense is much more difficult now when you have like a federated, harder to capture, harder to detect adversary. So looking to sort of how we're developing these technologies, we're not just thinking about these threats in Ukraine, we're thinking about how these lessons learned can start to apply onshore, CONUS. Really, like, you see in the news, Langley, the East Coast, some of these other bases, it's a lot harder to track some of these drones now than it has ever been in the past. We're learning other ways to sort of defeat what we typically thought were ways to detect these drones. And I think it's more than just how do we actually deploy the asset, it's how do we defend ourselves at home and ensure that we're not losing sight of the people and things and assets we've got here.
Yeah, absolutely. I think to y'all's point, there's been a lot of this cat and mouse game of UAS, counter UAS in Ukraine. And so as soon as they deploy one system, they enable a lot more GPS jamming and back and forth. And now we're dealing with fiber optic drones and how do we combat that? So it has been a really unique window into that warfare. As you're talking about kind of preparing for the future, I'd like to use that to kind of transition from the present, what we're currently seeing, into potential future conflicts. So former CIA Director Bill Burns has publicly spoken about this directive within the Chinese military to be ready to take Taiwan by 2027. And President Xi Jinping has talked about how there's no such plans. But in December, they just launched their largest naval deployment since 1996, projected power out to the first island chain, and showed that they can effectively blockade Taiwan. So having that recent event, how do we apply lessons that we're currently learning to prepare for the potential of that conflict? And how many of those lessons do apply, and how many of those are just unique to that Ukrainian-Russian conflict?
So they've projected power beyond the first island chain. I think last week they had ships right off the Australian coast, and that was sending a message. So in terms of translating lessons learned, the scope of the problem set is dramatically more broad. So the ranges and the tyranny of distance in the Pacific are a thing, right? Just look at the map. If you ever see that Google map where if you look at the globe and from one perspective, it's almost all blue. The threat environment is way different from the things that we're gonna have to face, heaven forbid. And then from a leveraging autonomous systems perspective in the maritime domain, countering those challenges requires integration with the assets we currently have. And I think our view at Saronic is, we get asked all the time, are you gonna replace the surface fleet in the Navy? The answer is absolutely not. Those systems are gonna remain relevant, and their exquisite capabilities are a critical part of our deterrence as a country. And where we see our value proposition to the sea services for the US and our allies is how can we increase the range, effectiveness, and lethality of those platforms that we already have and leverage the investments that have been made and give them kind of an outsized performance. I think one of the challenges we have is really from a doctrine perspective, how do you change the way the Navy fights when you have various communities of interest, subsea, surface, aviation, and the equities, the funding streams, and the mission sets that they're tasked to support, even though they're all under one umbrella, under a service, they're radically different. So what we're focused on is how do we provide an autonomous kind of connective tissue layer that allows those warfighting functions that the sea services are required to deliver and expand what they can do without dramatically altering the existing procurement system and really just flooding the zone with really effective capabilities that are also future-proofed. I mean, at the end of the day, NVIDIA is coming out with a new chip every year. And if your system isn't designed to be able to adapt to the new technology at that pace that it comes out, you're going to be obsolete in 18 months, and it's all for naught. So,
And that's a huge fear. I just got back from DC last week. We talked to House, Senate, various committees, and there's a real fear that, hey, if we bite off on scaled, and in my case, maritime systems, and nothing kicks off, how many warehouses of autonomous stuff do I have sitting, rusting, becoming obsolete, et cetera? And so when you start talking, and there was some good discussion around dual use companies this morning. Hey, are you a true dual use company? Are you not? This is where I think the power of true dual use comes in. So for example, Terradepth, we've got an MSA with ExxonMobil right now to do recurring port and terminal surveys. The commercial world cares in a lot of cases about the exact same data sets that the US government does too. You want to find something on the ocean floor, you want to pick something up, you want to know the condition of what's down there, you want to know if something's down there. We all care about the same things. So there's real power in this kind of hybrid privatized model that I think you can bring to bear, especially to Duncan's point, in a preparatory environment, right? So we can go do mapping for certain entities on the gov side. We can go, then if it's not required, we deliver the pixels. We go do mapping for ExxonMobil in this case, right?
I think from a definition perspective, this probably tees it up for you. Attritable does not have to mean disposable.
Right.
You can have an attritable system that has a 20-year life cycle, but you have to be intentional about how you build that system and work closely with customers to ensure that you align to their missions to meet that price point, the performance, and also the resilience. So that's my foot stopper is attritable does not mean disposable.
So I know you guys don't want to have a sales pitch from companies, but this is a good opportunity to talk about logistics, which isn't the sexiest thing to talk about when we're talking about combat, but it's certainly one of the most challenging. And so I said we were a 3D printed drone company, but it's underselling the capability. We're actually a manufacturing company that prints drones at the edge. And so when the lights go off and there's a blockade, all the systems you're building in the United States aren't getting delivered to those first island chains at all. They're not going to make it. And even when you ramp up production, there's still the problem of delivering them. And so, to both points here, you don't want to print 10,000 drones and have them sit in a warehouse. We already have DRMO that has lots of systems that are just atrophying and going to be burned or sold probably on eBay to me. But as we look at what Excel provides, it's on-demand production. And so as conflict escalates, we can create capability in theater. And then the same system that you deliver to theater can be moved. And so, we tend to get schizophrenic about where conflict's going to be. Whether it's CENTCOM this week, it'll always be CENTCOM. But once it goes from, Asia Pacific back to the Middle East, those same Excel systems can be put there and do production. And so, to your point, it's not just printing our drones, it's printing capability and giving the capability to future-proof systems and never have a locked design. And so the goal is, and this is what scares folks in DIU, especially for the Blue UAS list, is that if the system's constantly evolving, we're not locking the warfighter into one design, it allows the system to scale to new payloads, new theaters, new parameters, engines. But we're so used to what we were given, and our tactics are usually dictated by the technology, and we made it work. And then you have the proliferation of commercial solutions, so the COT solutions that the warfighter would take, enter DJI to the party, and then you start seeing all these creative capabilities and TTPs. I don't think they should be looking to COT solutions. I think you give them a multi-mission platform similar to yours, similar to ours, and let them choose their adventure on the system. But certainly production should be on demand, and we should be able to scale it and then also throttle it back when conflict de-escalates.
Yeah, there are two really interesting points that I kind of want to double down on. One is the tyranny of distance. That's certainly true in the Pacific. And the second goes back to how are we leveraging our energy more effectively? If you think about the distances involved and needing to move all these assets out there, there's underlying a need to optimize how we use our energy, whether that's fuel, whether that's some other sort of hydrogen, let's just say. And when we think about the Pacific, a lot of the way that we win is just not losing the fuel and making sure that the fuel gets utilized on the platforms that need it most, whether that's a CCA, whether that's some fighter platform, whether it's some ship on the sea. And so I think increasingly, especially as you look to this Pacific threat and you compare it to what's in Ukraine, I think there is a need for some more exquisite systems, but certainly more efficient systems, even if they aren't exquisite or expensive. And that efficiency, whether it's book kept in terms of production at the edge, whether it's in terms of having assets where you need them most, or whether it's truly efficiency in how you leverage the energy that you have to propel your vehicles, your assets. All of that is certainly going to be at play, because that's not our home turf, and we're not going to easily be able to move JP8, avgas, whatever you need forward. And so how you leverage that energy becomes increasingly important.
And we're facing decades of underinvestment in the parts of the fleet that actually enable the fight. So if you look at oilers, the fleet oiler situation is an existential threat. So energy is a great point, and what the autonomous system kind of marketplace is allowing is not just ensuring that the US and RC services have what they need, but working with our partners and allies, which is the quickest and easiest way to counter that tyranny of distance problem. Is this has to be a together fight, and how do we federate warfighting capabilities in a way that's easily shared with our partners and allies, but works together, with the systems that we have, both exquisite and mundane.
And how do you get away from the over-reliance on C2, right? From 20 years of having FMV, and every ground force commander is passing this data back to JOCs, and they're making decisions as a coalition. How do you give that opportunity to the forward edge and allow them to make decisions? Or, like you just described in the very beginning, is autonomous. And so that's a policy issue, but we keep kind of dancing around it. But we're right at the cusp of it right now. Yeah,
I think the S&T community has always done great work, but I think there's time for upping the amplitude for stress testing these systems and having some accountability for, can you effectively operate in the environments we know you're going to have to? And if the answer is no, it doesn't mean you're gone. It means go back, do your homework, and come back with a solution that works. And I think fail fast is a phrase that's used often. In the events that Saronic's participated in, we've been in a zero defect mode, and we wouldn't have it any other way. But I think we need to enable more of that, where pushing these systems to their limits and identifying where those fail points are going to be. I would much rather experience it as a company here than have our sailors and Marines and allies face it when it counts.
Well, I think Chad brought up C2, and Rob's brought up allies now a couple times, right? In this federated effort that's going to be required. So one thing I think people don't talk about enough is data, right? So the U.S. military does exercises all over the world. I've done them, you guys have done them, a lot of people in this room have done them, and comms and data sharing is always a problem, and we always eke it out at the exercise and figure it out, and we claim victory. And we're like, yes, we could talk to each other, nobody got fake shot, we didn't shoot each other, great. But in real life, do we have the robust, resilient data sharing systems that we're going to need to conduct federated, allied operations, especially across a lot of these distances that we're talking about here in the Indo-PACOM environment? So
you talk about the PED relay for ISR platforms. That stovepipe exists in every theater, and you can't get it back to the States in time. And so we got to solve that at the edge for sure.
So do you know, this is a dirty little secret, but do you know how you get seafloor mapping data back from somewhere remote? You fly guys out, and you have them grab the hard disk drives, and you fly the hard disk drives back to the United States. That's kind of where we're at in a lot of cases. And that's what, Terradepth specifically and a lot of folks in the ecosystem are trying to prevent. We've got cloud systems, we've got secure systems that we can use to pass this data, share this data, and be responsible with keeping it secure. At the same time, it's just, you've got authorities and funding that you've got to get through, and that's part of what needs to change, I think, at scale.
And you hear the term JADC2 thrown around a lot, and it's almost said so often that you laugh a little bit. But the reality is, we really do need to solve it. If we actually had a meaningful way to relay this information and not have to ship a disk, it changes the game. Being able to make decisions on the fly changes the way that we face it.
So how does that play in? Because we've got, we've talked a lot about the heightened electronic warfare environment that has been going back and forth. And then I think it's fair to say that if there was a conflict in the Pacific, the electronic environment is going to be very, very restrictive. We need to be prepared to operate in a GPS denied, communications denied environment. And so if we're talking about this integrated mesh network of systems that all communicate and relay data back and forth, does that work in that environment?
So this is where the tyranny of distance can actually be helpful, because from an EW perspective, it's really hard to jam everything all at once over a broad distance, right? Pick two and really probably pick one. So how do you use that to your advantage and have systems that can create a mesh network and a concept of operations that's resilient in that system, where there's awareness across these platforms of who can talk and who can't, and allowing them to dynamically reallocate because they have contextualized decision making at the edge and the compute to support that. That's probably the one area where the tyranny of distance helps us. At sea, it is really hard to be blanked out across a group of platforms across the board. So
This is one of the biggest lessons learned from Ukraine, in my opinion, is the alt-nav, the GPS jamming piece. Well, all the lessons learned don't apply because you're talking about a linear battlefield, you're talking about ground-based systems, and you're talking about you have to penetrate this much space. It's very different in the other theater, but it's forced companies to emerge to solve those problems. And alt-nav is very different over water than it is, over a region that you have a map on. But it's a forcing function for DoD, and so I think to me, that's one of the unintended consequences of this, is that there's been a ton of young companies that have emerged within that space.
Well, this is an environment though that we live in every day because we're underwater. Like, we don't have GPS underwater, right? And so the answer, in a lot of ways, if we assume actually the worst, and you are completely blacked out, just like we are underwater, you need a priori knowledge, right? So the answer, in a lot of ways, is get out there, get the information you need before stuff goes wrong, and just assume the worst. So for us, it would be a high risk. I mean, how many times,
hard-fought lessons learned.
I didn't dive for 6 years in the SEAL teams because we were doing other stuff, but like, how many times was I on land with all the bandwidth in the world, and I had no comms?
Yeah.
A block away from the guys I needed to talk to, right? So it's always going to happen. You've got to actually go out there and do the work and get a priori knowledge of the area so that you can, for example, navigate underwater before you actually have to do it in real life with manned submarines, for example.
Yeah. So great discussion. I think we've got time for one more question, and I actually want to thread it back to, we had Stephanie up here talking earlier from NSTXL. In light of the fact that these autonomous systems are highly reliant on the latest tech, the latest semiconductors, the latest software in general, and we talk about implementing AI on these systems for automatic target recognition, things like that. That semiconductor industry is highly globalized, right? It's so specialized that for US to do it all domestically inherently is incredibly, incredibly difficult. So how do we ramp up our production of these autonomous systems while making sure that we fail safe our supply chains when they come from so many diverse parts of the world?
I think from our perspective, it's all about intentionality in how you build your stack. We wrap the platform around our stack and try to future-proof and ensure that we're applicable in every environment, whether we have a Blackwell that's coming in the platforms or down to the lowest level, more available systems, heaven forbid. If you have an inefficient network on your platform, everything else is going to be hard. And in the maritime environment, there's no dead reckoning. You can't use map data to help understand where you are. So you have to maximize the utility of every bit of compute you have on that platform. And when we started the company, vertical integration was viewed as inducing vendor lock. And it created a lot of fear amongst a lot of our customer set. And as it turns out, when we're conducting integrations with third-party systems, it's proving to be a huge unlock because we own those interfaces and it can expose them in an open API where we're batting 1,000 on sub 72-hour integrations with major C2 systems, payloads, and a variety of different types of payloads. So we see kind of the owning that network stack and designing with the end in mind. That allows you to future-proof so that you can kind of flex up and down as the supply chain fluctuates.
Completely agree. And what we've done is we've taken a bit of a different riff on this, right? So in the subsea autonomy space specifically, what you see is a family of very exquisite, very expensive, very engineering requirements-driven assets. And they're very expensive, very low volume, they're built to spec, and they break all the time. We operate these things every day, we break them every day, right? So what we've done in at least our development is, yes, you build around your stack, but we also go back to first principle. So for our asset that we're building, we basically built a World War I U-boat with no people in it. And so it's a diesel-electric snorkeling autonomous underwater vehicle. It's a huge high-energy truck. And so as sensors develop, as machine learning models develop, as we put more and more compute in there, as long as it needs to be powered, we can power that across time. And we make sure it's attritable. So I always tell the folks it's like the AK-47 of UUVs, because we want it to be simple. We want the parts to be readily accessible. We don't want anything that we can get from one or two folks. And I think that's got to be a driving principle going forward, because you're going to lose these things, especially in the water.
You say AK, we say if you could merge a Cybertruck and a Toyota Hilux,
There you go.
there we are.
We have
AKs, Hiluxes.
We have an analogy as well, but I won't drop it on you guys. But we've taken the exact opposite approach. We're partnering first, and so what we've done is we basically make sure that from tip to tail, we can make sure we get those components on every continent. That's allowed us to use commercial solutions where it's applicable, and then in every region that we're really eyeing, there are solutions for gimbal cameras. Are they as good as the ones we'd like? No, but do they work? Yes. And then propulsion is the big one. That's we design our aircraft around. Yeah, exactly. Partnerships. Let's add that to the stack. Our aircraft. My vision is that it looks like a NASCAR, right? With all the integrations we've done, and the DoD can come to us and say, this camera, yeah, we did it on this day. We know it works, and we've taken the ethos of MOSA and taken it to the extreme, and we're giving the SDKs to the warfighter. We're not charging for it. We're saying integrate what you want. That goes into the future-proofing concept, and it allows us to really de-risk the supply chain.
Yeah, and when they're not exquisite systems, a lot of the .mil-PF constraints that drive timelines don't apply, right? By the time you build a curriculum and a training program, the thing's obsolete by the time you start training sailors and Marines to use it. So.
And they're rotational personnel too, right? So you're going to train them every 2-3 years.
We're a little bit unique. So we started in the pandemic, which meant that everything was shut down. And so by nature of starting so late, or I guess not so late now, our entire supply chain is US and its allies, intentionally. We wanted to be dual use from the beginning and make sure that our first foray into aerospace and air mobility products would be with the DoD. But the cool thing is that the tech can be dual use for leaf blowers. And so the robustness of our supply chain is further improved by the fact that we're building something that can, readily be produced here in the US. And a lot of these components either can be directly utilized for attritable assets, or the same techniques, manufacturing techniques, R&D can be leveraged into a slightly higher end asset that can maybe go into a drone like you guys are building. So a pretty unique way to build towards that robustness. And when you build not just the actual supply chain, but also the design and software behind that to flexibly make a capability either more exquisite or really, really cheap, not just attritable, but expendable, that changes the kind of unit economics when it comes to going to war or actually providing a product people really need.
Yeah, awesome. Well, thank you, gentlemen, so much. It's been a pleasure. Let's get one round of applause for everybody.